All right, so hi everyone. My name is Kate Sills. I'm a software engineer at Agoric, and I work mostly on the smart contract layers. Today, I wanted to code with you the OTC desk contract that we've been working on, and it uses the Agoric platform. So, what do I mean by an OTC desk contract? The inspiration for this was a Medium post by Hasib Qureshi called Unbundling Uniswap. And it's a really interesting article. I highly recommend it. I'm going to focus on one part in particular. Hasib outlines a design for what he calls signature-based pricing. And effectively, it's a new form of over-the-counter or OTC trading. So typically, in the world outside of smart contracts, you would tell the desk that you want to trade, let's say, 100 ETH for USDC. And the desk would respond with a price. And if you like the price, you execute the trade. So without a smart contract, you're trusting the OTC desk and you're signing a legally binding OTC agreement. So Hasib had the following idea to use a smart contract instead. He said that the OTC desk would reserve the assets on chain and then cryptographically sign a quote off chain and give it to you. So if you like the quote, you can submit it on chain to the smart contract, which verifies the signature and fills the order at that exact price using the on chain reserves. So what exactly are we going to be building today? Well, we're going to be building an OTC desk where the trades are atomic and quote unquote trustless. So we don't have to rely on the OTC desk, right? We don't have to rely on them to keep their promise. The creator keeps all profits. So this is as opposed to something like Uniswap, where the inventory providing or the liquidity providing process is decentralized. In this case, the creator is going to be the one keeping all of the fees and profits and adding all of the inventory. Our OTC desk is going to be able to use any pricing mechanism, which is really cool. So this means that they can, the creator of this contract can look at what Uniswap is doing and underbid them, right? It can use any kind of pricing mechanism that we want. It can also stop quoting when the market is crazy. So something like Uniswap famously provides liquidity at all times, even when the market's going crazy and we don't actually know what the right prices are. So our OTC desk contract is going to allow us to make higher profits because we're going to be able to stop quoting when we don't know what the price should be. Let's see, so our OTC desk contract is also going to be able to trade fungible and non-fungible digital assets. And this is actually without doing anything extra. This is just part of our platform, part of what I'll go into in a bit, the ERTP layer, which is our token layer. And it also uses another contract, which is our covered call option contract as a reusable component. So I'm really excited about this. I think you guys will really like it. But I want to go over the differences from the OTC desk that we're going to be building today compared to the one described in Unbundling Uniswap, the article. So our OTC desk today is going to have on-chain quotes, not off-chain quotes, right? And it's going to be validating the quotes through what we call invitations to join the contract, so not cryptographic signatures. And I'll go into what invitations are in a bit, but we're not going to be using cryptographic signatures today. All right. So let me start with just a little bit about the Agoric stack. So first, of course, this is, the Cosmos code with us, right? We are built on top of Cosmos, on top of Tendermint. We will be deploying a public blockchain built on Tendermint with DeFi integrated from the ground up. On top of that, we have the Agoric VM, and this is what provides the distributed JavaScript runtime environment. So all of our smart contracts are written in a subset of JavaScript, and you're going to see some interesting ways that we make calls to reflect the distributed aspect of things. So there are some things where the objects are going to be remote to where we're coding, and we're going to have to call it in certain ways. So on top of that, I mentioned ERTP, or the Electronic Rights Transfer Protocol. And this is effectively our token standard, and it defines the fungible or non-fungible tokens, or digital assets or electronic rights. On top of that is Zoe, which is our smart contract layer. This is our smart contract runner, and it also performs escrow and other necessary tasks such that you don't have to do it when you're writing your smart contract. On top of that is the user-defined contracts, and so the covered call and the OTC desk contract that we're going to be building today. All right, so can everyone see my screen now?
Yeah.
Great. So let's go ahead and get started. I am going to assume that people have followed the getting started instructions on our website and that you have a local version of our example encouragement dapp. I'm going to walk through a little bit of that, but mostly I'm going to assume that. So if you haven't gotten to that point, please head over to our website, agoric.com, and go to the documentation page, and it'll show you how to get started. So I'm going to be using Node 14 throughout this. So let's see. So I'm going to type in Agoric init OTC desk. That is going to create a folder, so I can cd into that. And then I can run Agoric install. So this will take a little bit. So there we go. And then we're going to be working on specifically the contracts today. But this sample dapp that you're given has a front end. It has the deploy scripts. It has everything that you need to kind of get your dapp up and running. But we're going to be focusing specifically on the contracts today. So let's cd into the contract directory. And let's do a yarn test there and see how we're doing. All right, cool. Okay, so let's move over to VS Code at this point. So let's open up the folder that we just created.
Someone asked if we can make the font larger for the terminal.
Oh, the font larger? Sure. Let's see. Let's see if this does it. Is that better? We're actually going to be switching to VS Code at this point, so hopefully that'll help.
Looks good.
Okay. All right, so in our sample dapp that we got, there is a contract folder, and within that there's a source folder and a contract file. So what we are going to do is actually take out most of this contract file. So I'm in contract.js, and I am just going to remove the contents of this. And let's do that as well. So basically, I just have a blank contract file, okay? And then let's move to the test directory where there's a test for this contract. And let's do the same thing. So let's see, let's keep that. And let's get rid of the tests that we have so far. So our testing framework is Ava, and we've really been enjoying it so far. And the cool thing is that what you're able to do is, let's go ahead and get our testing environment up. So, let's see. Oops, that is not what I wanted. Let's try this again. The cool thing is the ability to just be able to run it and with a watch parameter and keep it going. So let's open that up. Let's just have the terminal. And let's take a look at the Explorer. Okay. All right, this is what I wanted. Okay, so we're in the OTC desk right now. Let's move to contract. And let's go ahead and get our Ava test going. So we want to do test contract.js, watch. Okay, watch mode is not available while debugging. Let's go ahead and fix that. All right, let's open up the terminal. Let's do that again. Sorry about that. npx ava, and then let's actually cd out of that. px ava, and then test contract.js. All right. Okay, so we didn't have any assertions, right, because we took all of them out. All right, so let's actually set this up to watch. So this will be running while we are building our contract. All right, and let's actually change our, well, we'll do that later, I guess. Okay, all right, so first we're going to be building the covered call contract. So let's start with test-driven development and write down some of our conditions and test assertions. So normally we would have the long-lived Zoe on our testnet, but in this test we're going to create a new Zoe, so that's what we're doing here in this line. And let's actually write down a few things. So let's make up a scenario where Alice is going to she is going to want to trade some, let's see, let's say that she has some NFTs that are magical items. So she's going to try to trade a magical wand item for some fake currency that we call moolah. Okay, and let's see. Alice is going to give a contract invitation to Bob, who will provide the moolah and buy the magical wand item. Okay, so and what we actually want to provide, right, is a covered call option for Bob, and a covered call option is the right, but not the obligation to buy the magical wand. Okay, so let's start making some assertions. So let's have Alice create what we call an installation. So let's see. Create a covered call installation. All right. So this is the first thing that we need to do, and you may notice that I'm using this E notation. So what this E is a way for us to call remote objects, and we will get a promise back. So we can call remote objects somewhat as if they were local, without having to use any different API, without having to use any different messaging. It just works. So I can call a method on this remote object as long as I use this E notation. All right, so first we're going to have to bundle our software. So let's see, so we have the path here. So what I'm going to do is I am going to actually bundle it. So let's call that covered call bundle. And let's see, await bundle source. Let's rename this to covered call path. All right. Okay. So let's just do a quick test. So in Ava, t.is is just a test of equality. So let's test that the bundle that we get back from doing the installation is the same thing that we put in. All right. Yep. Cool. It passed. All right. So let's actually make some digital assets for Alice. So we're going to use ERTP to do this. Let's first create a magical item kind of mint. So in ERTP, I'm going to assume here that people have read a little bit of our documentation, but I'll try to explain as well. In ERTP, to create any kind of digital assets, you have to hold this object called a mint. And we're going to create that, and it comes as part of this kit of information about this type of digital asset. So there's going to be other objects in there, such as a brand, which specifies the type, an issuer, which is kind of the publicly accessible facet or object that's part of this mint that's actually publicly accessible. And so you can give the issuer to other people, and they can use that to validate their payments. So let's go ahead and create that. So let's call this the magic item kit. And we're going to be using ERTP here. So we are going to make the issuer kit. Sorry, I have two cats in the background, so they might make some noise at some point. Let's see. So let's call this magic items. And we are going to need to, for it to be a non-fungible token, we're going to have to use a specific kind of map here. So let's see, sorry, I can't see any of the comments right now, so let me know if there are any questions. So we are going to say that this is a particular type of amount math. And let's go ahead and import this. Let's see. All right, so we imported mathkind from ERTP. That gave us this string set. And so what this means is that for any kind of magical object or magical item that we want to create, we can describe it as a string that's part of a set. So let's see. So an example of this would be something like sword 1 or magic wand, right? So we can use any kind of string here and it'll work. All right, so we've created our the mint for our magic items. Let's go ahead and do the same thing for an imaginary currency that let's call moolah. And for that, we're going to use the default math kind, which is just natural numbers. So basically what's happening here under the hood is that for ERTP to know how to deposit things in purses or withdraw things from purses, it needs to know how to add and subtract digital assets. And that may vary a lot based on what kind of digital asset it is, right? So if it's just a currency, what we're dealing with is just natural numbers. So the value of moolah might be something like 20 or 44, right? Or 1,000. But the value of our magical items might be something like sword 1, right? So this is the way that you can create fungible and non-fungible tokens in ERTP. And I'm kind of glossing over this right now, but if this is still confusing, please take a look at our documentation. All right, Okay, so our one test still passes. We've started to create the mints for our items. And so let's go ahead and mint some things that we can give to Alice. So let's see. Let's have Alice start with this magic wand that we made. So first, let's create an amount. Let's see. And what an amount is kind of the description. It's not actually the value itself. So an amount is like saying, hey, I'll give you $5, right? Like when you say $5 in that statement, you're not actually transferring anything. You're just talking about it, right? So that's what an amount is. And so that's different than a payment in our system, which actually holds value. So in order to make this, we can use what's called the amount math from the Magic item kit. So let's go ahead and do that. And let's see, let's say it's a magic wand of, let's see, what we specified earlier. So this is the magic wand amount. So if we ever want to talk about this specific magic wand, we can use this reference. And let's go ahead and actually mint that. So Alice's magic wand payment. And we're going to mint this specific amount. So again, the amount is just the description, the payment that we have just minted. So this is the only way to actually create value in the system. This payment is what actually has value. All right. So let's do just a little check here. Okay, let's see, it said it failed. I think that was, oh. Okay, so here's one slightly tricky thing. So we have this helper called harden, and what harden does is it effectively does a deep freeze of an object such that it can be passed to someone else and they can't alter any of the properties. So let's go ahead and add a global harden here so our ESLint doesn't complain. All right. And I don't. If you guys have set up the fix ESLint and fix prettier errors on save, it's so nice. Just being able to fix that automatically. All right. Okay. So we have our magic wand payment. So let's go ahead and create some moolah. Or actually, let's not do that for Alice. We'll do that for Bob. Okay. So let's go ahead and create a small test here that will just show that we've created something of value. So what we're going to do is we're going to use the Magic Item Kit Issuer to confirm the payment and give us the amount back. So let's just confirm that the amount is in the payment is the same as what we minted. So this is a dumb little test, but it'll help us. So let's go ahead and use the issuer. So we can say Magic Item Kit Issuer, get amount of, and let's get the amount of Alice's magic wand payment. And let's confirm that that is equal and it is a promise. So let's add an await there. All right, so that passes. So this payment has the amount, or has the balance of the magic wand amount that we made. All right, great. Okay. So far we have our code installed on Zoe for this covered call that we're going to be making. Right now it is just this blank contract. So let's actually have Alice create an instance. So first, let's see. So we're going to be using Zoe for this. we're going to be calling start instance, which is the way to take the code that we have installed and actually create a smart contract instance, something that's running. So we are going to use the covered call installation that we made earlier. And something else that we're going to do is add the issuers to this contract. So we're going to specify them with what we call keywords, which are just string keys that help us make this a little bit nicer. So let's go ahead and do that. We call this an issuer keyword record because it has keyword keys and issuer values. So right now that is undefined, so our tests aren't passing. But let's go ahead and define this. All right, so we're going to use hard in there to deep freeze it. And let's use the keywords underline asset. And let's say that we're going to put up the magic wand amount. So let's add the magic item issuer here. And let's say that the strike price, so a strike price in a covered call option is what you want what you want someone else to give to be able to buy the underlying asset. So let's say that that type is the moolah issuer. All right. Okay. So let's see. Cannot destructure property creator facet of undefined is set as undefined. All right, so let's go back to our smart contract. And all of the smart contracts, they must have this particular format. They must have the start function that's exported. And that start function takes in ZCF, which is what we call the contract facet side of Zoe. So this is going to be the side of Zoe that the contract has access to that it can call methods on. Okay, and this start function needs to return, it has a number of things that it can return. So it can return a invitation that gets sent back to the creator. It can return what we call a creator facet, which is an object that's kind of the admin object that gets returned to the creator, or it can return what we call a public facet, which is an object that's going to be available to everyone. So right now we are just going to try to return a creator invitation so that Alice gets that. So let's harden that as well. And in order to create an invitation within this contract, we're going to call a certain method on ZCF, which is the make invitation method. All right. So the make invitation method, it requires an offer handler function, and I'll go into this in a bit. But let's just fill it in for now. So we're going to call this make the call option function, and it needs a description. So let's just call it make call option and any custom properties, but we'll leave that out for now. All right, so let's just fill in that function. Okay, let's see if this passes. Cool. So we are going to get a creator invitation back. So this is, Alice is calling start instance with this installation, right, with the actual covered call code, which is this that we are still building. Since we returned a creator invitation here, it's getting sent back out to her here. So let's add a little test to make sure that this is actually a real Zoe invitation. So a Zoe invitation is effectively an ERTP payment that allows you to join a contract. So I'll go over that again in a bit, so it's okay if it doesn't make sense right now, but let's add that test. So first, let's actually get the Zoe invitation issuer. So back up here in the magic item kit and the moolah kit, we saw that the issuer was part of those kits, right? So the issuer is a thing that can confirm payments for us. It can allow us to claim them to make them exclusively ours. It can do a large number of things, but it's basically the source of truth of whether a payment has value or a purse has value. So there is an issuer associated with Zoe invitations. So let's go ahead and get that. And again, I'm awaiting this call because it's a remote call. And so let's use that invitation issuer here. To get, let's actually say, let's just ask it if it's live. So this will ask the issuer, do you actually know about this payment? Is it something that's in your system? And let's change this to truthy. All right, let's hope that that passes. Oh, it's not truthy. Okay, let's see what's going on here. Okay, so let's add an await here. All right, cool. So that passes. All right, excellent. So let's go ahead and move on. So so Alice has this invitation. She's going to want to actually escrow her magic wand, and when she escrows her magic wand, she wants to get an invitation for Bob to perform the other side of the trade, right? So Alice escrows the magic wand using her invitation. All right, so in order to actually escrow and make an offer, Alice is going to have to call Zoe offer with her creator invitation. So this is the way that you redeem the invitation and actually join the contract. She's going to need a proposal, which I'll go over. Let's just spec that out. And she is going to need to add some payments. All right. And this gives her a seat back. And a seat is basically her position in the contract, and she can call methods on it while the contract is going on, while her seat is still active, and see what her current allocation is, see how things are going, and actually get her payouts, the results of her offer back at the end. So let's go ahead and define her proposal and her payments. All right, so Alice's proposal is going to have a couple of items. So first there's the give, right? And then there's a want, and then there is a exit rule. Okay, so first we decided that Alice was going to escrow the magic wand, right? And that she wants Moolah back. All right, so let's call this underlying assets, or underlying asset, and the amount, well, we're going to just use this amount. So she's going to be giving this amount, and this, again, this is just the description, right? An amount is just a description. It's the payment that actually holds the value. So let's say that she wants, this is the strike price. She's going to want, let's say, 20 moolah. So let's define that. Okay, so 20 moolah, we use the amount math that we got from the issuer kit. And with the value of 20. And then, so for this to be a covered call, it's going to be an offer that's only good up to a certain deadline. So we're going to use the exit rule here in Alice's proposal to set that deadline so that her offer is automatically canceled after this deadline. So we're going to use the exit rule after deadline. And we are going to specify a timer and a deadline. Let's say the deadline is 2. So the deadline can be anything that the timer understands. So depending on the timer, it could be block height, it could be some kind of UTC time, it could be anything that the timer understands. So we're agnostic as to the exact format of that. It really depends on the timer. So let's make sure to actually import the timer. Let me just copy and paste that in. Let's get rid of that. Get rid of that. All right. So this is just a tool that we have as kind of this this timer that we use for testing and things. So let's go ahead and make that. Let's put the console log in there so it has it. All right, so we've created this timer. We've made our proposal. Now we need to put the payments together. So the payments need to have the same format as what we said that we're giving, right? The payments need to match what we said we're giving. So Alice's payments, let's harden this as well. Let's say underlying asset is the keyword, and we are going to be paying the Alice Magic Wand payment. All right, let's go ahead and harden this. Okay, so cool. So that worked, but there's not a lot going on in our contract yet, right? So let's add a few more tests. So let's say, let's test what we get back as the offer result. So Alice's seat here, we got back from Zoe. So that means that Alice's seat is in the same remote area as Zoe is, and we need to treat it as remote. So we're going to call, when we call methods on it, we're going to use E as the eventual send. So let's say get offer result. And let's confirm that that is something like made option. Okay, and it is a promise, of course, so let's await that. And currently it is undefined. All right, that makes sense. Okay, so in our offer handler here, let's go ahead and type that. In our offer handler here, the offer result is whatever we send back here. So let's say, what did we say it was? We said made option with no period. Okay. So let's see. Let's go ahead and rerun that.
At this point, you might maximize your window to see more of it.
All right, is that better?
Yes.
All right, cool. Okay, so let's see. So we have successfully given back the offer result that we want, but not much is happening still, right? Okay, so what we actually want here is we want to make an option for Bob. So we're going to create an invitation specifically for Bob. So actually, we want this to be an invitation. So let's say Bob invitation is the offer result there. And this invitation is actually going to be an option, a financial option. All right, so let's do what we did before and write a test just to confirm that it is actually an invitation. It's not going to be yet. This test is not going to pass, but we will make it so. All right. So let's do what we did before. So we are going to call this an option, ZCF make invitation. Let's call this exercise option because that's what Bob will be doing if he accepts this invitation. And let's call it exercise option again. This is just the description that indicates where in the code the invitation is coming from. All right, and let's return that option. Okay, and let's actually spec out the offer handler for this. And we'll type it. All right. Okay, let's run this again. Okay, so we have successfully created the option for Bob, but there's no trading going on here, right? So if we get Alice's payouts, they're not going to resolve. So let's go ahead and try to do that. All right, so the payouts never resolved, and so the test failed. All right, let's see how we're doing on time. Okay, so let's go ahead and let's actually do a trade. Okay, so we've given this option to Bob. And it has this exercise option. So let's actually, so the offer handler, it has a seat parameter that gets passed in. And the seat is effectively the position in the contract. So when Alice exercises her creator invitation, let's call that the sell seat. And when Bob exercises the option that he got, let's call that the buy seat. Okay. So it's only within the exercise option offer handler that we actually want to perform the trade, because that is when Bob has escrowed his sides of things too. So let's use a helper called swap exact, and we're going to pass in ZCF there, and we are going to add in the sell seat and the buy seat, and let's go ahead and import that. So in order to import things, we have all of these helpers that come from the Agoric Zoe package under contract support. So let's import swapped exact there. And let's see. So what are we missing? So let's return an offer result. So let's just send a message saying the offer was exercised, right? And let's see. So we have a failure there. It still has not resolved. So that is because Bob has not been offering his sides of things, right? So let's actually add Bob's position. So Bob is going to be fulfilling the other side of this trade. He's going to be submitting 20 moolah and getting the magic wand. So let's go ahead and see things from his position. All right, so let's say that Bob gets his invitation. So first, Bob receives the invitation from Alice. He doesn't trust Alice, so he wants to inspect the invitation. All right, so the first thing that Bob can do is claim the invite, and that will effectively make it exclusively his. So he can use the invitation issuer to claim Bob's invitation, and let's call that claimed invitation. All right, and now he can get some. He can look at the invitation and inspect it and get some details on it and make sure that those match what he wants. So let's call a method on Zoe called get invitation details, and we'll pass in the claimed invitation. All right, so let's write some tests for this. let's say that the details installation, well, that should match the covered call installation, right? So Bob can check the code. The code of the contract he's invited to is what he expects. All right, so that passes. Let's see. He can check and see what has actually been escrowed. So let's call that underlying assets, and this test is not going to pass yet. But let's say that that actually matches what Alice gave here. And let's also say that you can look up the strike price. Let's get that from up here too. All right, so our tests are currently failing, but that is to be expected. Let's say, so in order for Bob to actually effectively make his offer, he's going to need to know what the deadline is, right? So let's call that the timer, the time authority. And let's look at the deadline as well. Okay, so right now none of this information is coming through, but we can add that. So when Alice creates the option for Bob, what she can do is she can add custom properties. So let's go ahead and describe those. So let's say, what did we say? Underlying assets, strike price, timer authority, deadline. And let's see, I called this time authority. All right. So the underlying assets are whatever Alice has escrowed, right? So we're going to say that this is sell seat, get proposal. So this is just getting the proposal that Alice made. And this is what she gave. The strike price is what Alice wants. The time authority is the timer that she used for her sell seat. And the deadline is going to be the deadline that she made for her sell seat.
I have a question from the audience for you.
Sure.
A couple. The first is this an option or an offer? He was thinking he would use an offer for both sides. And I thought you might want to expand on that.
Yeah, that's a very good question. So there actually is going to be an offer on both sides if Bob chooses to perform the trade. So he'll get this option, which is an invite to join the contract, and he can choose not to join the contract, but he'll still have that option as a Zoe invitation and simultaneously an ERTP payment and financial digital asset. So we have a lot of concepts coming in at once here. But yeah, so we're going to create an option for Bob, and we are going to, right now he's just inspecting that. So this is actually this claimed invitation. Let me put this here. This is the option. So he has the opportunity to be part of this trade, but not the obligation. And so he could take this and sell this to someone else in a different contract, which is really cool. It's kind of we've kind of got inception going here. One layer can actually feed into another layer. So he could go and sell this, or he can use it to perform the trade. So just to test the contract, we're going to use this to actually perform the trade. So let's take a look at our tests. Are we still failing? Okay, so we need a deep equals here. Were there any other questions, Dean?
Yes, whether the deadline is optional.
So normally in a contract, the deadline is optional. Currently in the covered call that we're about to build, we're going to require it. And I can show you how to require it in the code. But the reason why we want to require it is because we want the quote to not be good forever, right? So prices move, things change. You don't want to be making quotes that are always going to be good, right? And we also don't want Alice to be able to withdraw her assets before Bob makes the trade, right? Then it wouldn't be a trustworthy contract. We'd be depending on Alice to keep her promise to keep the assets there. So having the Alice having the deadline or having the exit rule of after deadline, that ensures that Alice cannot withdraw her assets until after the deadline has passed. All right, so let's check our tests. Cool, they are passing. All right, so Bob is able to inspect his invitation, and he's able to see that Alice has put in underlying assets that are of the particular amount of this magic wand. He's able to see that the amount that she's requesting, the strike price, is 20 moolah. And he's able to see that he better move quickly because the deadline is at time 2, according to this timer. Okay, so let's actually write the code for Bob to take this option, which he could sell to someone else, and actually exercise it. So he's not going to sell it. He's going to keep it and use it to join this trade. So this is going to match the same code that Alice used for the most part, but we're going to use this claimed invitation. Bob is going to have his own proposal, and Bob is going to have his own payments. And this is going to result in a seat for Bob, which is his position in the contract. All right, so his proposal is going to be the mirror image of Alice's. So he is going to give, and his keywords could be anything here. I'm just going to keep the same ones for consistency's sake. So he is going to be providing 20 moolah. He's going to want the magic wand amount. Okay. Magic wand amount. And one thing that I think is really cool about how we've set up ERTP in these contracts is that it doesn't matter. The contract doesn't care whether it's a fungible or non-fungible good. It treats it all the same because we have the amount math that we used up over here that we created as part of the issuer kit that handles all of the arithmetic and the calculations for us. All right, so we have Bob's proposal there, and Bob can actually use the default exit rule, but I'll put it in here anyways. So Bob can exit on demand. And so that means that he can pull out his assets at any point. He can exit his seat at any point. And this is fine because no one's relying on Bob. He gets the opportunity to perform this trade, but no obligation to. All right, so let's actually create those payments for Bob. And we need to use the same format that he used for the give. So there's going to be a strike price. And let's call this Bob moolah payment. So let's go back up here. And normally Bob would not have any access to the mint for this. So we're just going to pretend that these pieces of code are separate. But let's actually create the moolah payment for Bob up here. So we're going to use our moolah kit, we're going to use the mint, and we're going to call mint payment, which is the only way to create value. And let's move up moolah 20. All right. Okay, let's call it Bob payments. All right, let's see how we're doing. Okay, so cool. Our tests are passing so far. So let's actually see what the offer result is. And again, this is going to be remote because we got it from Zoe, so we're going to need to call it with E, the eventual send. And let's add a test here. We'll await that. And let's say trade successful. Okay, so instead it was offer was exercised. Okay, that makes sense. We put that in. Let's trade. Okay, cool. So that passes. All right, so no one is getting their payouts yet. So let's actually put that in. So let's take the swap out for 1 second and let's see what happens. So let's look at Bob, and let's get his payout for the underlying assets. Okay, and let's get his moolah payment too. Let's call these payouts. Okay, so we took the swap out. So Bob, without any swap, without any kind of trade, Bob should just be getting what he got back. So let's take out that swap and let's exit Bob's seat without doing anything. Okay, so let's write some tests. Say deep equal, and let's use the magic item kit issuer to get the amount of Bob's payout. And what he wants is the actual magic wand, right? So let's put that in here. It'll fail, but at least we know where we're headed. And he does not want any moolah back because that's what he gave. So let's add a test for that. And let's make a 0 amount here. And again, amounts are just description. We're not minting anything here. So we want to use the amount math, make, and 0. Or actually, we can do one better, and we can say get empty. All right. Oh, payout. All right. So as we can see, this is failing. We did not get what we wanted yet. So let's go ahead and let's take this part out and let's perform this swap. So let's see if Bob actually got what he wanted. Fantastic. So let's make sure that Alice got what she wanted. So let's just take this and change it for Alice. Are there any questions on this while I'm going through and changing this? Dean,
I answered one question about how can the option be resellable if it's not minted? I'm just saying that it's Zoe that does the minting.
Yeah. So that is an excellent question. Yeah, so within Zoe, there's this invitation issuer and this invitation mint that mints the invitation. So back when we called ZCF make invitation, that was under the hood minting invitations, minting ERTP payments that Zoe knows about. So
And
that's
each
excellent.
invitation is basically a non-fungible token.
Yeah, it is. Yeah, the invitation is a non-fungible token, and as you saw, we were able to. There's a helper here called get invitation details, but if we just called, I'll write it here in a comment. If we just called invitation issuer get amount of claimed invitation, and then we did a little bit of fussing with what we got back, we would get this same information. So, so we're giving you some helpers here, but under the hood, it's really just the same kind of issuer that we've seen in the past with information in the value of the digital assets. All right, so let's see. All right, so let's actually change this so that Alice, we expect that Alice is going to be getting empty. So let's do, let's write that up. So mount math get empty. And again, the really nice thing is I don't have to care what empty is. I don't have to care whether it's a fungible or non-fungible token because the amount math handles it for me. And she is going to get her 20 moolah back. Or actually 20 moolah from Bob. Okay, so let's see if that passes. Cool. So it took us a bit, but in about an hour, we were able to create a complete covered call contract. So I hope you all were able to follow on at home, and we're going to move on to the OTC desk contract unless there's any further questions. No questions? Cool. All right, so let's go ahead. Let's stop this. Let's go ahead and rename this to covered call. And let's rename this to test covered call. All right. So let's create a new file here. Let's call this OTC desk. And let's create a new test file. Let's call this test OTC desk. All right, so let's basically reuse what we had. Oops. So let's paste this in, and let's actually strip out all of the internals like we did before. Let's do a similar thing to the OTC desk, but let's actually keep the Bob side of things, because what we're going to be doing is that Alice is going to be creating quotes using her OTC desk contract, but from Bob's side, he's going to be receiving options in the same exact way that he received an option from the covered call. So we can actually keep all of Bob's parts of this. So let's take out Alice's and keep Bob's. All right, so I am going to comment those out for now, but let's rewrite Alice's part. All right. Okay, so what Alice is going to want to do is she's going to want to be able to do three things. She's going to want to add inventory, remove inventory, and make quotes for Bob. So the quotes will be in the form of a free option. And so she could take this option and sell it to Bob, but we're just going to give it to him here. Given to Bob. Okay, so let's go to our contract and just start adding some things. So rather than starting with a creator invitation as we saw before, let's actually return another one of the things that we can return, which is a creator facet. And this is just an object that the creator of the contract instance can use without having to escrow anything yet. All right, and this is just a plain object, so let's just fill that in. And let's add 3 methods. So add inventory, remove inventory, and make quote. Okay, so going back to our tests, we're still going to be using this covered call path, but let's rename it to covered call. And let's add another path here for the OTC desk contract. So we're going to be using both of these contracts, and this is what Dean likes to call the DeFi Legos part of things. All right, let's call it path. Okay, so we still have Zoe here. We still want to be able to use the covered call installation, so let's keep those tests. But let's do the same thing for our new OTC desk contract. So just going to do that. Any questions while I'm doing this change? Or anything to add, Dean?
Nope, not yet. Other than lots of people like to call them DeFi Legos, and this is where the magic starts to happen. So, rubbing my hands.
All right.
Hey, everyone pay close attention because the magic starts to happen here.
Yeah. Yeah, this is where the Legos all come together. Okay, so so now we've installed the covered call and the OTC desk contract that we're still building. Let's actually use the same items that we used before. So we had we created the mint for the magical items for non-fungible magical items, and we created the mint for the fungible tokens, the moolah, which is our fake currency. And we had these specific amounts that we used. So we had this magic wand amount, we had this 20 moolah amount. All right, so let's go ahead and write some tests for Alice. So Alice is going to want to be able to, well, first she's going to want to be able to actually make a contract instance of the OTC desk. So let's go ahead and do that. So we call start instance with our OTC desk installation, and we don't need to put in any issuers actually. So let's call this undefined for now. And then for the terms, we're going to be using the covered call contract within this. So let's actually pass in the covered call installation here. All right, and we have already decided back over here that Alice is going to get a creator facet back. Okay, so on that creator facet, and let me back up a second. So again, we're calling this method on Zoe. What we get back, we're going to have to await because it's a promise. And then any object that we get back that's not a record, that's not just a flat object with keys and non-function values, anything that we get back that's actually a real object with methods, that actually is going to be also remote. So we have some more documentation on how all of this works on our website, but I'm not going to go into it right now. But we are going to let's see, let's call the add inventory method. And in order to add inventory, or let's see, sorry, actually what we want to be able to do rather than add inventory is we want to make an invitation to add inventory. Make add inventory invitation. Let's do the same thing with remove inventory. This will allow us to easily escrow payments within Zoe without having to handle it within the contract itself. So that's why we're going to make an invitation, because we're going to actually be putting value in. Okay, so she is going to be calling make add inventory invitation. And she is going to get an invitation back. Invitation. All right. Okay, let's add one of our tests from before. So in the covered call, we tested whether the invitation that we got back was actually invitation as recognized by Zoe. So let's add that test here. Let's get the invitation issuer. Okay, and this is the add inventory invitation. All right, so let's actually go ahead and get our testing set up here. So before we were testing the covered call, now we're going to be testing our OTC desk contract. Let's see if this works. Okay, so our test failed, and that makes sense because we're not returning anything yet. All right, so let's go ahead and do that. So we saw earlier how to create an invitation inside the contract. So we're going to call ZCF make invitation, and this is going to mint an invitation within Zoe. So we need to pass in an offer handler. So let's call that add inventory. Let's also say that the description is add inventory, and this description is just saying where in the code this invitation came from. And let's return this invitation. And let's just kind of start this offer handler. All right, and let's type it. Okay, as we saw before, an offer handler, it takes in a seat. So let's say seat.exit. And we're going to be doing some things with this seat, but let's see what happens. So our test passed, that's great. All right, so let's write some more code, some more tests, and then we'll go back to the contract. So Alice wants to escrow. So let's see. So let's say actually that up here we're going to mint a whole bunch of items for Alice and Bob. So let's say that Alice actually gets a whole bunch of items. So let's say a couple swords in there. Magic item kit, mount math, make. So we'll put our magic wand in there. Oops. Let's also add some swords. All right. And this right now, this is just the amount, so we haven't minted anything yet. And let's make 1,000 moolah for Alice, because why not? Use our moolah kit. We'll just create the amount first. Okay. And so let's go ahead and create Alice's inventory. So you can see how easy it is to mint fungible tokens, non-fungible tokens. It's all the same thing. The only thing that changes is how they are described or what the value looks like. All right. Okay, so this is Alice's inventory. We want to be able to add that inventory. So we're going to use this invitation that we get to make an offer. So let's call this the Alice add inventory seat. That's what we're going to get back. We're going to call offer. We're going to use the add inventory invitation. Let's call it add inventory proposal and add inventory payments. Okay. Okay, so we have Alice adding inventory here, but we haven't yet told the contract about magical items or moolah, so ZCF doesn't know anything about the issuers yet. So we're going to need to add that part. So here, when we say make add inventory contract, let's take in an issuer keywords record. Oops. And let's actually make sure to save that in ZCF before we start adding anything. And basically what this is doing is that this is creating a local amount math, and it's saving the issuer in the brand to Zoe so that it knows about it. So then anything that we do further can be synchronous. We don't have to, even if the issuers are entirely remote, we don't have to make any remote calls when it comes to the issuers and making calculations. So in order to do that, let's import save all issuers from the contract support. This is a nice little helper here. So we're going to say await save all issuers. We're going to pass in ZCF because it's a helper, and pass in this keyword record that we got. And since we said await, we need to make this say sync. All right, so let's go back. And let's go back to our make add inventory invitation call, and let's pass in issuer keyword record there. All right. And let's call this underline asset, and we're gonna let's see, we're gonna just pass in the magic items kit issuer, and let's call this strike price. This is gonna be the moolah kit issuer. Actually, since we are adding inventory, let's just call this magic, and let's call this moolah. So in the future, when Alice makes quotes, she could be trading magic for moolah. She could be trading moolah for magic. She can add more inventory and trade for different currencies. We're not stuck with just these currencies or just these digital assets. All right, so when she adds her inventory, her proposal has give, want, and exit. So she is going to be giving magic, and it's going to be in the magic items amount. Let's call that amount. And she's also going to be giving moolah, and let's call that moolah 1,000 because that's what we used before. and she's not going to want anything because we're just going to be adding this to the inventory. One thing that we could do here, so this is kind of an extra thing that we could do if we wanted to really take this to the next level, is if we did want to have decentralized inventory collecting, if we wanted to have liquidity be decentralized, we could use something like Uniswap does here, where we could hand out invitations to add inventory and then give back tokens representing a certain percentage of the capital, a certain percentage of the inventory. But we're not going to do this here. We're just going to have Alice has sole ownership of all of the inventory, and she's able to add things, and it just gets dropped into the contract. Okay, so we're not going to want anything, and the exit rule we don't care about either. So actually, let's take both of those out and just use the default. All right, so let's see. So it is complaining. It says that there is a payment not found. Let's see here. Oh, so that is because we have not actually put in our payments. So let's say that it is the Alice Magical Items payment. And let's put in the 1,000 moolah as well. All right, let's see if that satisfies the test. Cool, so that passes. All right, so right now nothing is happening, right? There's no reallocation. If we were to check the payouts for Alice exercising this invitation for making this offer to add inventory, she would just get her stuff back. So let's actually take the items that Alice adds and add them to the contract. So we're going to do something a little bit tricky. We're going to create an internal seat just for this contract that will be used as the store of all of the inventory. So let's call that the market maker seat. So this is kind of a shortcut. We're not adding a proposal for this seat. There's no offer that's being made. We're not escrowing anything, but this make empty seat kit gives us a seat that we can use for accounting and things internally. All right. So let's use another helper here. Let's use trade. And what trade does is that you can specify effectively the delta between two seats, and it'll perform the reallocation for you. So we saw earlier the swap exact, which took everything from one seat and gave it to the other seat and vice versa. Here, trade is going to be taking a specified amount from one seat and giving it to the other seat. So let's go ahead and do that. So let's say trade ZCF, and we are going to be taking the market maker seat. So let's see, market maker seat. So the first seat that we're using is the market maker seat, and then we can specify the gains and the losses. So the market maker seat is actually going to gain all of the current allocation of the seat. All right, and then we have a second seat here, which is just the seat representing this particular offer of Alice adding inventory, and that seat is going to gain nothing. Okay. All right, so let's actually add a little check here so we can check the proposal shape. Let's make sure that the want of the seat is not anything. So the reason why we don't want the seat to want anything is because it's not going to get anything. So if it wants anything, this isn't going to pass. All right, cool. So let's see. So we only have about 30 minutes left. I think we're going to be able to get through this. Do we have any questions? Anything that I'm missing, Dean?
Nope, so far so good.
Cool. All right. So Alice was able to add her inventory. Let's actually just do a little check here, like we've done before, to see whether her offer result is what we would expect. And let's say inventory added is what we want. So that's going to fail. Oh, because it needs to be on the seat. And so what we're going to do is we're going to return inventory added here. Cool. So that passed. Let me just make sure. Okay, so let's go ahead and make a quote for Bob. So since we're going to keep the same test for Bob, let's actually have Alice make a quote that's of the same amounts as before. So she's going to trade a magic wand for 20 moolah.
There is a quick question,
Uh-huh.
which is, given that it's a one-sided offer, why is the make inventory using offers here instead of just doing it directly?
Yeah, that is a very good question. So as you can see in this, we're not wanting anything. So we're not really checking offer safety here. But what we are able to do is we're able to use the escrowing capability of Zoe and not have to handle that within the contract. So, and that is really nice because we would have to somehow maintain purses within the contract that escrowed all of those. We'd have to be very careful. We'd have to be extremely careful about bugs that could potentially allow someone to extract the value from those purses. And so when we're using Zoe to escrow all of the digital assets that are involved in this contract, we're depending on Zoe for security purposes, and we don't have to actually handle all of that code ourselves. So you can kind of think of it as, I like to think of it as almost like a like PayPal or something if we're doing if we were doing online commerce. So Zoe is handling all of the payments for us. We don't have to worry about that. But that does mean that we are using the invitation style here in order to take advantage of that. Okay, so let's actually go back here. Let's make an offer, or let's make a quote for Bob. So we're going to use our creator facet. We're going to call make quote. And we haven't written this yet, so let's see what we want to put in. Let's say we'll specify the assets, the price, the time authority, and the deadline. And we will get an option back. Okay, so let's define these. So the assets, let's call this underline asset, and let's actually go back to our covered call and get these. Okay, so it's going to be the magic wand amount is what Alice is going to be offering Bob. What she wants from Bob is this strike price, which we're going to define as moolah 20, and the time authority, well, that's going to be this timer, and the deadline is going to be 2 again. Okay, so let's bring in that timer that we created in our other test. Cool. Okay. So let's test that this option is actually something that is a Zoe invite. It's not going to be because we haven't built it yet, but let's go ahead and test that. Okay, so that is false. So let's go ahead and write the make quote. So we said it took in assets, price, a time authority, and a deadline. And we want it to return invitation. So actually, rather than returning the invitation there, what we're going to want to do is create a new covered call instance like we saw in our previous test, but this is actually going to be within the contract. So this is going to be where the DeFi Legos come in. Okay, so first, let's up here, let's make sure that we are getting that the term that we passed in, the covered call installation. Okay, and also let's get Zoe. So ZCF is the contract facet side of Zoe. We're going to want to get the Zoe service side of Zoe, but we can get that from ZCF. So we're going to want to use Zoe as if we're a user. All right, so within make quote, let's make an instance. So this is effectively, let's go back to what Alice was doing here when she made an instance. Okay, so let's copy and paste that in. Okay, so we had an issuer keyword record, and we had a call, a start instance. So we want to keep those things. Let's add eventual send here. So we're going to import E from Agoric eventual send. And the reason why we need to do this is because Zoe is going to be remote even from our contract. Okay, so the underlying assets, let's see. Actually, we don't need to pass that. We can just pass ZCF get terms issuers, and that will effectively copy all of the issuers that we have in this contract over to the covered call contract. So we started that instance. Let me just look at something over here. All right, cool. So we got the creator invitation. We want to actually make an offer. So we're going to make an offer in the same way that Alice did, but we're going to make it from within this contract. So we're going to use that creator invitation. We're going to have a proposal, and we're going to have payments. Okay, so our proposal is going to be pretty simple. It's just going to be that we are giving the assets and we want the price. And we're going to have it be after deadline as well. So we're giving assets, we want the price, and exit is going to be after deadline, and the timer is going to be the time authority, and the deadline is going to be the deadline. Okay, so this is going to be very similar to what we saw Alice do. Okay, and then for the payments, we're going to do something a little bit tricky. So we are actually going to be withdrawing the payments from the market maker seat. So we're going to use a special helper for that. We're going to say withdraw from seat, and that takes in ZCF. We're going to pass the market maker seat, and for the amounts, well, we just want to withdraw the assets. Okay. So these are our payments. Let's see. Oh, and we need to await that. Thank you, type system. And let's call this the cell user seat. So by user seat, this is something that's on the user side of things. Normally, we're talking about ZCF seats when we're within the contract. We have more documentation on that on our website. But this is going to be as if we were Alice, as if this was Alice's seat. Okay, so what we saw previously was that Alice, as her offer result, got an option. So let's just take that and return it so she can give it to Bob. Okay, and we have one last remaining task to do for this method. So when Alice actually, or when the OTC desk performs this trade, what we saw when we tested for Alice was that she actually got payouts back, right? So what we want to do is take those payouts and put them back into the market maker seat. So let's get those payouts by calling get payouts. And there's two functions here. There's get payout and get payouts. Get payout gets only a specific payment given a keyword, and get payouts gets all of them. So we're going to get all of them here. Okay. And that's going to be a promise that resolves when the trade actually occurs. So we don't want to await that, but let's add a then. And let's call the outcome payouts. And then what we're going to want to do is use another helper, which is deposit to seat. And the recipient seat is going to be in the market maker seat. The amounts, let's put that aside for now, and the payments are going to be the payouts. Okay, so we said await, so we need to make that a sync. And the amounts are just going to be the current allocation of the sell user seat. So this is going to be after the trade has happened. What actually did this seat get? Well, it's going to get the outcome of the trade, which is the current allocation, and that's going to be the amount of the payments that we're going to want to deposit. So let's clean that up. Okay, let me just check and see if I'm missing anything here. I think we are good. So let's go ahead and try to see if Bob's test will pass. So so we think we've created this option. Let's see. Oh, the reallocation failed to conserve rights. Let's see what's happening. Okay. Left and right have the same magic wand. Okay, so let's see. So did I name this the same thing? Okay. Oh, so when we said, when I wanted to make a quote, I should be using the same keywords as I used to add my proposal. So let me actually change that. Let's say magic and moolah. Let's see if that solves our problem. I think it does. Cool. Okay, so let's take Bob's tests and see if they pass. I'm going to uncomment those, start those running. Test failed. Alice seat not defined. Okay. So let's call this Bob invitation. And we already have this test below. You can take that out. All right, let's see. Moment of truth. Nope, still failing. Okay. Oh, we have changed what these are called. So this, we called this magic. We called this moolah. There we go. All right, so just to recap what we did. So we built an OTC desk contract that uses a covered call under the hood to make a trade between Alice and Bob such that Bob is given an option and he only has to trust the covered call contract. So what we did not do yet was actually write the code for the make remove inventory invitation. But I want to pause here because I think we're nearly running out of time and ask if we have any questions.
No questions so far. Thank you.
All right. So
I do want to. I would like to point. Can you go to where it spins up the new covered call contract?
Yes. So yeah.
I just wanted to emphasize that that's actually spawning an entirely new contract dynamically inside of this contract that is now a separate process that can be separate, or a separate running thing inside of the chain that can be separately inspected and confirmed, and communicate asynchronously with it. This could be launching, arbitrarily complicated, interesting network of other contracts. So.
Yep. Yeah. So this is really the DeFi Legos that we've been talking about, the, composability. So I didn't have to write, well, I did write it today, but if I were Alice, right, I wouldn't have to write the covered call contract. I would just be able to use the installation, and, perhaps Bob has seen it before in the past, so he trusts that code. And I don't have to ask Bob to trust me for anything, to trust the code that I'm writing, to trust that I'm going to have the assets between the covered call code and Zoe. All of those things are guaranteed. All right, so if there are no more questions, let's go ahead and finish this out. I'm gonna start on the make remove inventory invitation. So it's pretty similar to the make add inventory invitation method, but we'll go ahead and do that. So this is an offer handler. So of course it takes in a seat. We're going to want to return a invitation. Let's call the offer handler, Let's call the offer handler here remove inventory, and that is what actually takes in a seat. Let's call the description remove inventory. Okay, so we have a seat here, and we are basically going to be doing the exact opposite of what we did earlier. So I'll type it. Let's say inventory removed, and so the market maker seat is actually not going to gain anything. The outgoing seat is going to gain the exact thing that it wants. So the way that we're able to remove inventory is to specify what we want, and it'll be taken. Okay, so let's go back here. Let's have Alice make an invite for herself and use it. So we're going to use the creator facet. We're going to make remove inventory invitation. And notice we don't have to pass anything here. We're not telling Zoe about any issuers. Let's call this remove inventory invitation. Let's await that. All right. Okay, so like I said, we only have to specify the wants here. So let's say, for whatever reason, Alice is going to want to remove 2 moolah. So let's use our moolah kit amount math for that. Okay, and now let's actually make the offer to Zoe. And we don't need to pass any payments because we're going to be getting payments. We're not going to actually be adding anything. So let's call this remove inventory seat. And let's add a little test here. See if that passes. Oh, let's see. Okay, so we needed to harden this.
Remember someone asked in chat, how do you know what to harden? Well, there you go.
Yeah, certain areas of our system require things to be hardened. So that'll definitely decide things for you. We are working on making it so that the hardening happens automatically, so you wouldn't have to actually call that, but that's still in the works. Okay, so we got the offer result that we wanted, and so the inventory was removed. So there you have it. We have built our OTC desk. It's able to add inventory, it's able to remove inventory, and it's able, most importantly, to make quotes that are credible, that are actually the covered call options that we saw before. And it does so by using the covered call installation that we built today. So we're actually using the DeFi components in a composable fashion, and I think this is really exciting. So anyone have any questions before we close?
There are no questions in the chat list, though I'll keep an eye out here. I just wanted to add that, of course, this is in the context of the Agoric init directory, which has the contract that she was editing, and of course the API side and the UI. So in the last 5 minutes, she's going to sorry. In another session, you can imagine this OTC desk getting its web server so that the person who is doing the market making has the ability to manually decide what quotes they're willing to issue and approve quotes proposed by their AI or whatever it is. So the mechanisms to bridge to external systems are also an overall part of the system. So this is a really nice starting point for a more detailed future example.
Yep, and if anyone wants to take this further, you could actually build the front end for this and have this as a working dapp example. So you can, it wouldn't just be the contract side. You could actually create the front end for this as well.
Yep. And the code for this, I posted in chat. I have pointers to the code inside of our repository. The OTC desk is already there. Covered call has been there for months and predates OTC desk by quite a long time, and had been previously reviewed and used in other purposes. So. Well, thank you very much, Kate, for this. This was really, really useful and really great to see.